Hey everybody, how's it going? In this video we are going to talk about SQL Leetcode problems. And me personally, I never did Leetcode problems before, and this is the first time on this channel that I'm going to do SQL Leetcode problems. Now what I did is I went to the website, I filtered after SQL Leetcode problems, and I solved all the easy problems where you don't need the premium access to it. So all the free problems that you can also do at home. Now in these easy problems, there are already some problems with it that you have to think about it. And I take you with me, I take you into the discussion of the problems. I'm also going to take you to some places where maybe there wasn't the right answer in the first step. And this is for you to know about the way that you can solve the problems and about the teaching. So this is really important for me that you know the way that I'm thinking, so that you can apply this way also when you are solving these problems alone. Now what we also do, and this is, I did it especially in the last problem that we solved, I framed the problem, then I googled it, and then I found an answer on Stack Overflow, which is a very popular site for finding answers to problems. And then I adapted this answer to our problem, and then we solved it. And this is such an important skill for you to learn, is to know to frame the problem in the right way so that you can Google it and that you find the answer, and then you can just insert the answer with a little adaptation to your problem. Now this sounds very easy in theory, but in practice, of course, you need some practice with it, and you have to do it over and over so that you get better and better at it. But the great news is that you don't need any degree for it. All you need really is the internet access and thinking about what problem you're really trying to solve. And if you really internalize it and understand this, then that means that all the possibilities in IT, what regards data science, data analyst, programming, whatever you want to do is really open for you. You can really do it, because when you have the internet access and if you start thinking about the problems, you can figure them out. Like other people, many other people already put the solution in there on the internet, and you just have to follow the footsteps, so to speak, and you can really figure out any problems that you might have in the workplace. So this is really great news for you. Just one more thing before. The best way to support this channel really right now is to give the thanks. Now YouTube introduced super thanks button, so you can donate to me through a super thanks if you really appreciate the videos and you want to contribute to it. Then you can give me a super thanks. Aside from that, of course, I'm very happy about the likes that you can give, or if you can comment down below if you have a question. Other than that, I wish you great fun in the video, and let's get started. Alright, let's start with the easy problems. So the first Leetcode problem is going to be gameplay analysis 1. Here we can check out the SQL schema. Okay, so here we can see the code for this schema. Interesting. So let's read it. We have 4 columns: player ID, device ID, event date, and games played. 3 integer types and 1 date type. Primary key, and so on and so on. Okay, so write an SQL query to report the first login date for each player. Return the result table in any order. The query result format is in the following example. So here's the input, the player ID, the device ID, and the event date, and how many games played. The first login date for each player. Alright, so in this output, the player 1 first logged in at the 1st of March 2016. So this is what we give out. So because you have to try to understand from the text what the query wants. So in the text you can read for each player. And if you read something like that, that's like a signal word for each this, for each that. That usually means that you have to group the query. In this case, group it by the player. So that we definitely know that we have to use the group by player command in this query. So let's first select everything with a star from, what is the table called? Activity. Activity. Okay, so we have, so we can see here the differences from the output and the expected output. Okay, so we have the player, device, event date, games played, and the values here that come out. This is not a really nice formatting. It's quite hard to read, but okay. Okay, so what actually we want to get out? We want to get out the player ID and the first login. Okay, let's say player ID. So the first login is definitely the event date that we want. Event date from activity, and we want to group by the player ID. Let's also order by player ID. It's not necessary, but I just like it to be ordered by the player ID. So this is still not the solution. Oh yes, sorry. Okay. So we actually have to aggregate this function, the event date, and we want to get the first login, so we have to get the minimum of the event date. So let's say minimum from event date as the first login, because the minimum for each player from this event date, so the minimum from player 1 would be 1st of March. And because there are two dates, 1st of March, 2nd of May, and 1st of March would be the minimum. And that is the first login. That is exactly what we want. So let's run this now. All right, it is accepted. So we have the first login and the player ID, and we grouped it by the player because it's set for each player. And I would submit this code now. And it was a success. All right, so let's try the gameplay analysis. Okay, we cannot do 2 because 2 is in the premium category. Then let's do the next one that is for free. Customer placing the largest number of orders. The largest number, if you see something like this in the title, largest number, I already thinking in my head how I can translate this to SQL, and I'm thinking of the maximum aggregate. So probably we have to use maximum aggregate in this query. So it's just max function basically, MAX. All right, so we have a table with 2 columns, order number and customer number. Order number is the primary key. Okay, that is not really so important probably. So this is important, the text. So write an SQL query to find the customer number. Select the customer number for the customer who has placed the largest number of orders. Okay, so we have to get the customer number. Select customer number from the table is called orders. Let's just get the customer number. The largest number of orders. The test cases are generated so that exactly one customer will have placed more orders than any other customer. Okay, so we don't have to use any other differentiator because there will only be one customer with the most orders. So in this example, the order number 4 is the highest, and the customer number 3 has placed the highest orders. Okay. So we select the customer number, but we only want one customer number. So we say where order number equals max from order number. Let's try this. I'm not really sure if you can use that in the where clause. No, you cannot. But you can use it. Yes, that's right. You can use it in the having clause. Okay, so if you want to use a aggregate after a calculation, you can use it in the having clause, because the where clause always happens before the calculation. In the having clause, you can use it later after the calculation. So having order number equals max from order number. Now you can also read this from here. An aggregate may not appear in the where clause unless it is in a subquery. We don't use a subquery here. Contained in a having clause. So contained in a having clause is also an option. Contained in a having clause, which we did now. For a select list and the column being aggregated is an outer reference. So now we used it in the having clause. Let's run this again. Okay, so now it is having a problem because we don't group so the orders.order number is not grouped. So let's group it by order number. Let's group it by order number and by customer number. Okay, so we get a lot of customer numbers now. You know what? I think this was totally the wrong approach. So I just thought of a better approach here. So we want to get the customer with the highest number of orders. You know what we can do? We can just say order number. Let's give out the order number and let's order by order number descending. So this is a trick really how you can also order the things without using maximum or minimum function like an aggregate function. Okay, now we have a runtime error. Customer number, order number from orders, order by order number descending. All right, so now we have here the customer has the value 3322 and the order is going down 4321. And now what we can do is we can say we want to limit this, or we want to take top one. The top one means we only want the first query to take out. And because we ordered it descendingly, so we put the highest order number on top, we will get exactly the query in one row that we wanted. And that is the customer number with the highest order, which we get because we ordered descendingly here. So let's run this. We still have the wrong answer though. So let's see. Okay, because we still give out the order number, we actually don't have to give that out in the result set. The result says only the 3. We can also make the difference here. Order number should not be here. All right. So let's just take the 3 here. And it works. So let's submit this query. We actually get the wrong answer. So he made one time 3 orders, then the next time he made 6 orders, then again, probably here again, he made 13 orders. So we have to sum all of the orders together. Okay, so this is a bit more complicated problem than actually I thought, because we cannot just pick the one with the highest order in one row, which would be here probably this customer with a 16 that he ordered here 15 pieces at once. No, you have to sum all of the orders together that the customer made, and then you can compare. Okay, so we actually have to order by the sum from order number. Group by customer number. We group by the customer number, and we want to order by the sum from order number. Let's see if this works. All right, so it seems to work. So what we changed now here is we summed all of the orders together and we grouped it by the customer. So in this case, when we submit, we really should get all of these sums, all of these orders summed together from the customer, and therefore also expect the right results. So let's see. Still the wrong answer. So what do we get out here? We get out the value 3. Because in our case, we think the customer 3 made the highest orders. How much did 3? How much did the 3 ordered? So the 3 ordered here, 14, 12 is 26. So he had 26, and the 5 ordered 3, 6 is 9, and 13. 9 and 13 is 22. So in my opinion, our answer is correct. He says the customer number with 5 really did the largest number of orders. He had 3, he had 6, which is 9, and he had 13, which is 22. Or is it maybe the count, because he had 3 orders? Maybe it is the count. Let's see. How can I get back? Okay, so here's the description. Who has placed the largest number of orders? So I thought who has ordered the most things, but actually it is who has made the most orders. So that's why 5 was correct. And that's why the sum is not correct here, because sum is like who ordered the biggest amount, like the most amount of stuff. I thought that was it, but it's actually who made the most singular orders. Okay, so who ordered on most days, or how do you say it? Like who ran the most often to the supermarket, so to speak. Okay, so actually we have to make a count here to see that. Let's run this code. Okay, this is accepted again, and now submit. Okay, finally we have a success. Yay! So let's solve the next one. So this one, how was it called again? It was customer placing the largest number of orders. Whoops, no, we don't want to do it again. What was the next one? So salesperson is going to be the next one. All right. Let's write the query. So this is a table, blah, 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 4 columns, 5 columns, okay. We have 2 tables now. So one is the table salesperson with 5 columns, sales ID, name, salary, commission rate, hire date. One is the company column, company table with com ID, which is probably the company ID, name and city. And another table, orders. So 3 tables now. So you can bet that we're going to make a join here between tables. Okay, so let's read the description. Write an SQL query to report the names of all the salespersons who did not have any orders related to the company with the name red. Okay. Write a query to report the names of all the salespersons who did not have any orders related to the company with the name red. Okay, so first let's get the names of all the salespersons. What do we have here? We have here the name, select name from the salesperson table. Salesperson. So let's get all the names, just to look at the names from the salesperson table. Alright, so we have some names here. John, Amy, Mark, Pam, and Alex. Now, which of these people did not have any orders related to the company with the name red? And then we have to any order. Okay. The query result format is in the following example. Here we have all the tables. Here we have the output. Amy, Mark, Alex. So they did not have anything to do with the company red. So now the question, of course, is we have the names from the salesperson table. How do we get from the salesperson table to the company red? So we have a company table here, and we have actually a name red, a company red. But how do we get to the company table? So we see we have 3 columns here, company ID, name, and city. The company ID, can we connect this one to the salesperson table? It doesn't look like it, because we have here the sales ID that is not fitting to the company ID table. So we need another table in this one case. Okay, so now we have an orders table also here, which is helpful for us because the orders table has 2 things. It has the company ID and it has the sales ID. So we have to utilize this orders table so that we can connect the salesperson with the company table. All right. So we can start. So let's start from the salesperson table and let's join the orders table here. Join. So we're going to call the salesperson table SP, and we're going to join with the orders table. And the orders table, it's actually called orders, yes. Join orders O on O dot sales ID equals to SP dot sales ID, and that's actually how you make a join. So you search for the common column and then you join them together. Now you always have to think with the join, what actually in the end do you get out of it? Because if we run this again, so remember now we have 1, 2, 3, 4, 5 values, 5 names. And if we run this again, we will have John, Pam, Pam, Alex. Okay, we just have 4 values here. So it seems like we already lost one on the way. We already lost Amy here. We lost Amy, Mark, and Alex. No, Alex is still here. We lost Amy and Mark because we joined with the orders table. Because they actually don't have any orders, Amy and Mark, but they have to still get out in the end. So the question is, how do we get to Amy, Mark, and Alex in the end? I have an idea. So so we selected here these people. What we can also do is we select all of the people that actually do have orders related to the company red, and then we say we want all the names that they are not in this list, so we want to make an exclusion. So I think that will be a good way to get to the solution. So first, our problem is going to be the exact opposite now. So now we want to get all the people that have orders with the company red. Okay, so now we selected the name and we already joined the orders column. And now let's also join the company column. We join the company C on C.com ID equals S equals O dot com ID. So now we also joined the company column. And why did we do that? Because now we can select with the where clause. Where, and now we want the company, which we already shortened here with the C dot name. We want to have the name equals to red. So what do we get out now here? We get all the names from all the sales persons that have orders, and also that have orders related to the company name red. Invalid column name red. We didn't really want to make it a column name. Okay, maybe if we write like. Okay, and we have an ambiguous column name name. Ah yeah, because name is probably on multiple tables. It's here in the salesperson table and the company table, and we want to, so we have to say which name we want to get. We want to actually get the salesperson's name, so we write sp.name. So let's run this again. Great, so now we have John and Pam, and we assume now, because of our query, if we wrote everything correctly, that John and Pam are actually these persons, that they have connections to the company red. Specifically, they got orders from the company red. Okay, and now we simply ask select me the names from which table? From the salesperson table, where, and now comes the trick, where name not in, so basically exactly how you would write it in, say it in English. Give me all the names where the names not in this list, and we just made the list with a company red. So any other name we want to get out now. And let's run this code, and you're going to see we are going to get these other names now that we just excluded before. They are Amy, Mark, and Alex, and this is accepted. So this is the trick. We make the query other way around, and then we just exclude it in the where clause. Let's submit this. And it's a success. Let's move to the next one. There was the salesperson table. So this is premium, but here we have actors and directors who cooperated at least 3 times. All right. So we have one table, actor, director, with 3 columns. They are all integers, actor ID, director ID, and timestamp. And the text is, write a query, SQL query for a report that provides the pairs actor ID and director ID, where the actor has cooperated with the director at least 3 times. Return the result table in any order. All right, so here we have 1, output, because the actor 1 and the director 1, they cooperated at least 3 times. Actually, they did, yeah, exactly 3 times they cooperated. Okay, so the 1-1 combination is here 3 times. So we have to count somehow this. We have to count how often we get the pairs, actor ID and director ID. So first select actor ID and director ID from actor director. All right, so exactly like in the example table. Now the question is, how can we count the combinations of both? How would I do it as a person? So I would look at this table and say, I have an actor with 1 and I have the director with 1. So first I look at the actor ID, and then if it's the same as director ID, then I count 1. And then how can I write this as a query? I'm thinking maybe about something with the row number. So the row number function you can use to count something. So you can use row number over, let's do without a partition, and let's just order by actor ID is row number. Just to give an example, now we make a row number which is just counting. Okay, so we still need a comma here. So this row number is just counting the number of rows. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 rows here. And now I want the row number actually to count the different combinations of actor and director. So if I order by actor ID and director ID, so let's do this. I order by actor ID and director ID. I order the row number in this case. Then I would get the correct ordering which I would want. So the question is, when do I want to count the next? So I can also use a partition in this row number. That means I'm splitting my result set and I start the counting with 1. So now I have the counting because I just have the order by in this row number clause. I have 1, 2, 3, 4, 5, 6, 7. I'm counting the complete result set. Now I can also partition that, and I think I'm going to partition it by actor ID and director ID. Yes. So if I partition it by both of them, partition by actor ID and director ID, what does that mean? If I partition them by both of these parties, by both of these columns, then that means that any of the column changes, so the actor ID is changing or the director ID is changing, then we're going to start to count on 1 again, which is exactly what we want, because we want to count the pairs. So because we ordered by actor ID and director ID, they will always stand here one on top of the other. And if anything changes, for example here in the 4th row, the director ID gets up to 2, so it's changing from 1 to 2, then our counting should start from 1 again. And this is what partition by says. Partition by actor ID and director ID says if actor ID or director ID changes, then we start counting from 1 again. So I believe this is exactly the counting that we want, and we can see here now in the result set we have 1, 2, 3, and then we started 1 again. Perfect, exactly what we want. And now we have 1, 1, 1. No, actually 1, 1, 2, because the last one also has 2 combinations, 2 and 1. Great. So we already figured out, I think, the most part of this problem. And now we still have one thing that we have to solve, and that is we still have to make a where clause. Where, so the requirement was where the actor has cooperated with the director at least 3 times. Okay, so we take this row number that we now created, this row number function, and we say it has to be bigger or equal to 3, because the cooperation should be at least 3 times. Let's run this code. Okay, the window function can only appear in the select or order by clause. That is a problem indeed. We cannot use the window function here. But what we can use is, I believe we have to use already the concept of subquery. So now we say that we use this one as our first query, and we write with And this is just our assistant query, so to speak, to get our real final query. So we say with, how can we call this first query? What would make sense? Like a name that also makes sense would be actor with actor director count as, so we call it actor director count, and we say it is, so this is the query to count the actor director combinations. That's why we call it like that. And now we want to select the final query. We actually want to select, what do we have to get out in the end? We have to get out the actor ID. And we want to get out the director ID from our query that we just did, actor director count. And now we can use the where clause because we already defined the query here, and now this row number is like a normal column because we called it here row number. We call the column the row number, which is maybe not the best descriptive name here, but for now we call it like this. And we can say now we can use this as a normal column in the next query, which we couldn't do before because it was in the same query. And now we say where row number is at least, so it's bigger or equal to 3. So now we should get out the correct query. Okay, so we actually cannot use order by here in our temporary table, but we can use it here in the next column. Doesn't really make a difference. We don't need to order, but I like to order anyway. Can delete this one. All right, so we have the expected output 1, 1. And we can now submit our code and see if it also runs. No, it's actually the wrong answer. Interesting. So why is this the wrong answer? This is really not such a great formatting here. So what is the difference between expected and my output? So I got this output 1, 1 here very often. 1, 1, 1, 1, 1, 1, 1, 1. It seems that I have the right combinations, but because I didn't use distinct, so I didn't use the unique combinations, he will give out because I didn't use the unique combination here with the distinct clause, he will give me out all of the combinations that I get here, all of the times where the row number is really bigger than 3 or equal to 3. So actually we are pretty close to the right solution. All we have to do here is we have to use the distinct combinations. I'm sure if we submit now, that we are going to get the right solution. And we did it. So this was the question, actors and directors. Let's go for the next one. Wow, there are really a lot of questions under premium here. But let's go with the next free one. Sales analysis 3. That seems like already a bit harder because it's 3. I mean, must be harder than 1 or 2, right? Let's see. we have two tables, product and sales. Product table has 3 columns, product ID, product name, and unit price. Sales table has 6 columns, seller ID, product ID, buyer ID, sale date, quantity, and price. They're all integers except for one date column, and here there are 2 integers and 1 string column, so a varchar column, also called a string column. That basically just means here is written some text in this type. Let's see, we have product names, looks like phones, S8, G4, iPhone. We have a sales table and an output. And what does it actually want from us? Write an SQL query that reports the products that were only sold in the first quarter of 2019. That is between 2019 1/1 and 2019 3/31 inclusive. Return the result table in any order. The query result format is in the following example. Okay. So he gets out here one product with the product name S8 because S8 was only sold in the first quarter of 2019. Is that correct? We have the S8 here with the product ID 1. Product ID 1 is here and it was sold in 21st of January, and that is the first quarter. Okay, 2 times it was sold. So based on this, we definitely have to know somehow how we can get out the quarter. And this is just a function that you just have to know. If you don't know the function, you can also just Google how to get quarter in SQL or in MySQL, whatever you're using. And then you will get a query. So in my case, I think I know what the function is that I need. But let's first select, just to get a bit used to the table, select the product name. Actually, we want to get out product ID and product name, right? Yes, the output should be the product ID and the product name from what table? From the product table. Okay. From product. So we have the product ID 1, 2, 3 and the products S8, G4 and iPhone. Now we want to filter this to get only the S8 out, because the S8 was sold in the first quarter. Now the big question is, how can we filter on the first quarter? Let's first join the other table, because we actually have to get the sales table. So we call this product P table, and we want to get the P.product ID and the P product name. And we want to join on the sales S table. How do we want to join it? We want to join it on the product ID from the sales table with the product ID from the product table. Okay, and now we want to actually get the quarters out here. And we can do this with the date partitioning function, which is called date part. So in the date part function, you can give the date part function 2 arguments. That means you write 2 things in the brackets, and you want to give him what partition do you want to get from which part do you want to get from the date. So the date part function, you can decide which part you want to get from the date. And I don't want the day, I don't want the week. You can use all of these arguments, but we actually want the quarter here in this case. And now we also have to give the column, because there could be theoretically, there could be a number of date columns here, and we have to tell the computer which date column actually we want. And the date column is called sale date here. So we want to sale date, and we call this column sales quarter. In this quarter we got the sales. So let's run this code. Okay, so we have an error here. Invalid column name P. Because I wrote here P minus product ID. Of course, I wanted to write P point product ID. We have a result here. Let's look at this output. All right, so this is interesting. We have the first column which says the product ID. We have the second column which says the name from the product, so SA G4 iPhone, and we have the third column which is a sales quarter column. And here we have the sales quarter 1, the sales quarter 1, the sales quarter 2, and the sales quarter 2. Now we want the product that was only sold in the first sales quarter and not in any other quarter. So this is an interesting query. We cannot just include the first quarter. We cannot just say where, or actually we can, where date part from quarter sale date equals to 1. So that being said, we really want the first quarter. If you're not sold in the first quarter, then you're not going to be in the result. But this is not the only requirement. You can also not be in any other quarter. As the text said, we want only in the first quarter. So this is going to be our second requirement. And the quarter, which we are going to write like this, date part quarter sale date, should not be, so should not equal, or can we say it like this? Should not end date part So I'm thinking if we say date part should not be 2, 3, 4, it doesn't matter, because we still are going to get out this G4 here that is in the first quarter. So what I'm thinking is we have to make a list . We have to make a list from phones Actually, this join comes before the where clause. I don't know why that was still working, but usually it should be in this order. Of course, this is not working here now. So let's think about this one more time. We want to get only the products that they are sold in the first quarter, and they cannot be sold in any other quarter. So what I'm thinking is we are going to ask for the products that they are sold in quarter one, of course, and they should not be in and p.product ID not in, and now I'm going to exclude. I'm going to make another list with all the products that they are sold in either the second, the third, or the fourth quarter. And I'm going to say, if you're in this list, then I don't want you in my result set. So I'm going to select here the p.product ID from product P, and I'm going to join this again with the sales table. S.product ID equals p.product ID. And I'm going to say where date part quarter sale date is bigger than 1. So why do I do this? So I'm going to make a list now here of product IDs that they appear in the quarters after the first quarter. And then I'm going to exclude this list from my result set. In this way, I make sure that I only get the products that they are in the first quarter and not in any other quarter. So I work with exclusion here. Let's run this code now and see if it works. So I like my result because my result gives me only the one S8. Now, of course, I still have another column here that I should not have, which is the sales quarter column. But other than that, I like my result here. So we are just deleting this sales quarter column from the final result. And we are going to run this again. Perfect. Now we have a runtime error. You have attempted to run code too soon. Oh my god, I'm sorry. Please try again in a few seconds or subscribe, of course. No, I'm gonna wait a few seconds. And we are accepted. Nice. So we have the 1 in the S8. And now let's submit the code to see if it runs against all the test cases. And actually we have the wrong answer here. So why is this still the wrong answer? Oh wow, we have a lot of columns here, and we also have a lot of columns. But we even have much more than they have. So what is the problem? So it looks similar in the beginning. So we have 11 HZ var, 32 IEO, 47 CDPEDT, 44. Okay, I think I know the problem. Again, we didn't do a distinct, so we get a lot of columns. So you can see here we have 32 AEO again. We already had it here in the beginning. So what we forgot is to take unique values into our result set. So let's run this again with distinct. Actually, I could have just pressed this submit button again. Time limit exceeded. No. Let's try again. It takes too long. Wow. These are a lot of products. Might be a little bit too much. Whoa. So why do we get so much now? Select distinct product ID, product name. So this should actually shorten the query if we get that distinct. Why is this? So maybe the performance is just not strong enough because we did an unperformant query. That could be the problem. So the question is, how could we reach possibly a better performance on this query? How could we reach a better performance? Or is that even the right question to ask? Because this looks very weird here. And there's so many things. Why are there so many outputs? Maybe we can join. We can put the where clause already in the join. So instead of limiting it here to date part equals 1, we can already say this in the join. So if this is not the first quarter, we don't even want to join the products, the sales to the products. And then we can give a requirement here to the join, and date part from quarter sale date should be equal to 1. Now we can use this requirement. Let's test this one again. Okay, this is expected. Let's try to submit this one again. And it worked. So this really improved greatly the performance of my query, and I could make it work. So I'm faster than 67% than all of the other queries. That is not like hugely good, but slightly above average from the runtime. In our queries, we really don't focus on the performance. We just want to get it right. Now, of course, once you get it right, you can start to think about performance and how to make the query work even faster. But as an analyst, usually runtime is not your biggest problem. It's really trying to get the right solution, usually. Of course, it never hurts to think about also the performance side of things. But enough talking. Let's move on to the next query. We did now the sales analysis 3. Let's try to do user activity for the past 30 days. How many do we have left anyway? 1, 2, 3, 4. 4 queries. Okay, that doesn't seem too bad. User activity for the past 30 days. 1. Write an SQL query to find the daily active user count for a period of 30 days, ending 2019-7/27 inclusively. A user was active on some day if they made at least one activity on that day. Return the result table in any order. Alright, we just have one table that is called activity, and we have a user, a session ID, activity date, activity type. Let's select first the right columns that we have to get out. So we have to get out the active user and the day. Let's get out the activity date as day. And we get out the user ID as active users from the activity table. Alright, of course this is not yet the right query, but we already have the correct structure here. We have the activity date and the user ID. Now let's see what we get out here. We have dates here, where it was active, where the user was active. Right. Write an SQL query to find the daily active user count for a period of 30 days, ending on the 27th of July. So they really have to be active for 30 days consecutive. So on the 20th of July, there were 2 active users. On the 21st of July, there were also 2 active users. 22 active users, yes. 21, also 2 active users. Okay, so we count the distinct user ID because we only want to count it one time on any given day here. So let's count the distinct user ID. Distinct because we want to count it only one time. On this day, for example, we just want to count the user one time and not 3 times. That's why we say distinct and we say count, because we want to get the number of active users. And we want to group by activity date. Okay, now we have 25th of June and we have 21 of July. And here we have something very different. We have 20 of July and 21 of July. We have 2 and 2. Okay, so we have actually a time period here that we also have to group by. And that is where the column activity date should be bigger than the date difference from So now we are using the dateDiff function, and the dateDiff function, you can actually give 3 arguments to it. So 3 things separated with a comma, you can say. 1, you can say, what difference do you actually want to make? Do you want to make a difference in days or in weeks or in months? We want to make a difference in days. We want to make a difference between So actually what I want to write is, I want to get the activity date should be bigger than the 2019, the 27th of July 2019. Minus 30, so 30 days before. It should be bigger than the 27th of July 2019 minus 30 days, because we're going to get the time period from 27th of July minus 30 days before, because it should end at 27th of July. So let's run this. Let's see if this works. Okay, let's Google here. MS SQL date minus 30 days. Date add is actually the function, of course. The date add function and the dateDiff function we have to use. So we use the dateAdd function, and we want to use the day. We want to add minus 30 days. So we want to go 30 days in the past. And the day should not be now. It should be 2019, July 27th. Okay, so now we use this day, we go 30 days back, and then the activity date should be bigger than this. and the activity date should also be smaller or equal to this day, the day that we say here, 2019 7/27. So it should be bigger than the 30 days. I am not sure here if I need a bigger or a bigger and equal, because 30 days before, actually we also want to include, I believe, of 30 days. So I think we need also a bigger equal here. We want to include the day that is 30 days before this one also. Let's submit this code and see if it works. Okay, it seems to be the wrong answer. Let's see. So we already have a different understanding here from the first value. The first value is the 27th of June 2019. And for them, the first value is the 28th of June 2019. And the active users were 3. So we have this also, but it is our second value. So it seems to me that the bigger sign was actually the right one. And we don't want to include this day that was 30 days before. And if we do a bigger here, we exclude the first value here again, the 27th of June, which is also what we want. So let's submit this one now. Alright, so we did make a success, but this is really kind of bothering me here. It says that we are faster than only 20% of MS SQL submissions. So this is actually a nice way of saying we are slower than 80% of people. Okay, anyway, let's move on to the next problem. So we were at user activity for the past 30 days. So let's take article views 1. We have one table, which is the views table. And we have a text, which is called write SQL query to find all the authors that viewed at least one of their own articles. Return the result table sorted by ID in ascending order. The query result format is in the following example. So we want to find all the authors that viewed at least one of their own articles. Okay. So we have an author and we have an article. And we have the views. And we get the output 4 and 7. So the author 4 viewed his own article. How do we know that? And the author 7 also viewed his own article. Okay, so we know it because the viewer ID is basically also the author ID. So in this case, we can see the author 7, author ID is 7, the article is 2, and the viewer ID is also 7. So basically, if author ID and viewer ID is the same, then this person viewed his own article. So our question is, how can we write a query so that we get all of the ones out that they have author ID and viewer ID the same? That actually should not be such a hard query. So let's select first what do we want to have as output. We want to have an ID as output, and the ID should be the author ID as ID from the table views. Let's run this code. Now we get all the author IDs out, and we want to get 4 and 7. So let's say where, and basically the only requirement I see here is author ID equals viewer ID, because then the viewer ID is the same as the author ID, and that means the author watched his own article. So we have 7, 4, 4. Now you can see that we have 2 times the 4. So that means we want only the distinct authors. Now we have 4, 7, perfect. And now we want to order, because we also had a requirement that we should order. Return the result table sorted by ID in ascending order. Okay, let's order it by ID ascending. And there we go. Let's submit to see if it works. And it works. Great. So now let's try the next one. Top travelers. Now we have a table users with 2 columns, ID and name, integer and varchar columns. And we have another table, rights. So 2 tables, users and rights. Write a SQL query to report the distance traveled by each user. Return the result table ordered by traveled distance in descending order. If 2 or more users travel the same distance, order them by their name in descending order. The query result format is in the following example. Okay, return the result table ordered by traveled distance in descending order. So first we have the name, and now we have the travel distance. So how can we say how much distance Elvis traveled? Let's look at the tables for that. So we have here the Elvis with ID 19, and we also have here an ID column and rights table. So we already know we can connect the users and the rights table through the column ID. And now we have also here we can see ID 19 from Elvis. And we can also see here the ID 19 from Elvis. So we have here 400, whatever meters, kilometers, I don't know, 400 distance or miles. And we have here 50 miles. So in total we have 450 miles. Alright, so the first thing we have to do is we have to connect these tables, rights and users, and then we have to sum all of the distance together at the rights table. So let's select the name, and let's select the sum from the distance from the rights table. Sum from the distance is traveled distance From what? First we want to get it from the users table, users view, and we wanted to join the rights table, rights R, on r.id equals u.id, and now we want to group by the name, and after that we have to order, but let's first see if this one works. So we have Alex with 222 miles, and let's see the result. We can see Alex 222 miles. That looks good. Elvis 450. Where is Elvis? We don't see Elvis here. Why don't we see Elvis here? Alex, Alice, Bob, Donald, Lee. No Elvis. We also don't, we see Donald with 100 miles, even though Donald didn't have 100, he has 0. Interesting. So something is fishy here in our calculation. We get the wrong miles for Donald, and we also don't get Elvis, even though Elvis is in the result set. So something is not working. So what we definitely have to do is we have to always get the output of the names. Now what happens if you do a join is any name that is not in the rights table is going to automatically disappear from the result set. Now to prevent that from happening, you can do a left join. That means you're going to keep the left table, which is the users table, no matter what, even if if the user is not in the rights table. So let's run this again. Now we have Elvis in the result set, but Elvis has null, and Jonathan also has null. That's weird, because Elvis actually has distance traveled. You know what? We are going to do the query differently. What we are going to do is we are going to use the name, and we use the traveled distance. That is correct, but what we do is we don't join with the rights table, but we join with the table that we are creating right now. So this is also, you can also do that. You don't just have to use the what is given to you. So to speak, the rights table that is standing here, you can also make your own table that you are joining. And that is exactly what we are going to do here in the brackets. We are going to create this table, and we select now I know what the problem was. So we joined ID with ID, but actually we have to join ID with a user ID. So there was a trick here. We have to join ID with user ID. Okay, so we actually don't need to do this trick here that we just thought of. We can go back to this. And let's join on r.userid equals to users.id. Now this is not really helpful. That is, one time is called ID and one time is called user ID. This is a bit confusing here, but anyway, now we figured it out. You can think at this point also, how could you create this table better so you will not get this confusion? So one way, for example, would be to call this rights ID, and not just ID. Or to call this at users, you can call it the user ID also in this column. So that way you will not get this confusion that just happened. If you do that in the creating of the table, you can also leave less ambiguity for later people that they have to work with it. Okay, but now let's run this code again. Of course, now we have to call this one again. Sum from distance as travel distance. And now the miles look okay, but the problem is we have the Donald at null, and we don't really want the Donald at null. We want to have a 0 here, not a null. And for that we have the coalesce function, and that means coalesce means you are first gonna do this sum, and in case you get any 0, any null out of this function, out of the sum function, you should not write null, but instead you should write whatever you write in the second argument from coalesce. So if I write here, this is the null value, then he will write this is a null value in the result. So let's see how this works. Of course, now we have to put an integer here because this other one is also integer. So let's just write 1, 2, 3, just to demonstrate you how the coalesce function is working. So now we have here Donald 1, 2, 3. Because Donald was null before, we are replacing the null with whatever we write here. But we don't want to write 1, 2, 3. We actually want to write 0. In case it is null, we want to write 0. So now I'm seeing the values, and I see that the values fit very good with the other values. Of course, the ordering is not yet in place. That's why we have wrong answer. And we have to order by, what did it say? By name in the ascending order. Okay, name ascending. Still the wrong answer. Okay. Okay, I didn't read it correctly. Return the result table ordered by travel distance in descending order, and only if then the people travel the same distance. Then I should order by name. Okay, so the first ordering should be by the travel distance. So we can order by this one, and if they have the same, then we order by name. Still the wrong answer. Because we have to order descendingly. And it works now. Okay, so let's submit to see if it also works after the submission. Nope, if we submit, it's the wrong answer. So let's see. We have the value Bob 317, that is correct. Alex is also correct. Alice is also correct. And we have again Alice 0. Okay, so we don't want to get out the ones with 0. So Alice traveled 120 miles and Alice also traveled 0 miles. Okay, so the other Alice probably is another user ID with the same name that traveled 0 miles. And we don't want the 0 in the result set. So what we can do is we can make a join instead of a left join, and then we don't have it anymore. But we are not going to run the test case here. We have the wrong answer here in the test case, because here we have Donald with 0, we have here included. So in the test case we have Donald 0 included, but in the submission case we have Alice 0 excluded. So let's see what's about this Alice. So we have user 1 Alice and we have 19 Alice. And 19 Alice has 0 miles and is included, and here it is excluded. So it seems that there is a difference between the test code and the submission code. If we submit it like that, then it should be the right answer, but it's the wrong answer in the test code. Nope, still not the right answer. Okay, so we have Elvis, Lee, Bob, Jonathan, Alex, Alice, and now we have Donald 0 here. Now we do include the 0 again. I'm a bit confused. So this is accepted. And if we submit this, we get the wrong answer. Because the expected results has Alice with 0 miles in, and we don't have Alice with 0. But why don't we get Alice with 0 in our result set? Okay, we don't have Alice with 0 in here. Because we group by name, of course. So because we grouped by the name and not by the user ID, which was actually what we have to group by, that is why we get the wrong result. So grouping by name, we only have Alice one time here. It eliminates the other Alice name and it adds them together. So Alice 120 plus Alice 0 is equal to Alice 120 miles. And because we group by name, we don't have her here. So actually what we have to do is, let's see at the description again. Here we need this user ID. We have to group by user ID. So let's write user ID and let's run this code. But if we group by the user ID, we cannot give out the name in the end. So this is tricky. So we group by the user ID and we cannot give out name anymore because we can only give out what we group by here. So of course we could give out the user ID, but this will not help us. You know what, we are gonna do a different approach here. So let's select the name and let's select the traveled distance from the left join. And what we are gonna join, we are gonna join a query that we are writing right now. So we are gonna join, and let's do the sum from the travel distance already. So let's sum from, what's it called here in the rights table? Distance. Let's sum the distance as traveled distance. And how do we want to sum it? We want to sum it by user ID. From the rights table. Group by user ID. So now we have an advantage that we are summing it already here before we join it. And we call this table traveled on traveled. So now we have, like I wanted to say, we have an advantage because we already summed it here, and now we don't have to do all these summing and group by in the final result set, and we can just join the travel distance here now from this table, or we can just request the travel distance here because we already summed it up here in this table. So we call this left join the traveled table on, and we join on traveled dot user ID equals u dot ID, because we have here the ID in the users table. And now what do we want to have? We want to have the name and the travel distance. So let's see if this runs. Cool, it does run. It does run. Now, of course, we still have the problem with the null value here. We can solve this problem if we just write the core less function here and the second argument with 0. And what we have to still do is to make the order by. We still have the null value here. Okay. Because the null comes after we joined it. So it doesn't make sense to do it here, because here and this sum we do not have a null value because all of these users have a distance traveled. So the core less does not make sense to do it already here. We have to do it later after we did the join. And this is going to be in this place. So we're going to make a core less from travel distance and 0 as travel distance. Let's call it like that again. And run the code. And we have Donald 0. Yes. So now we have to order again all of the code. Order by should be travel distance descending. Actually, this one descending. And name ascending in case they have the same distance. And we have an accepted output. Now let's submit the code. And it runs with success. Alright, so this was the code for top travelers. Now let's do the last one that is for free, which is called group sold products by the date. Now we have the activities table. And we have only one table with only 2 columns. So looks simple enough. Let's see how simple it really is. The sale date and the product. Write an SQL query to find for each date the number of different products sold and their names. The sold product names for each date should be sorted lexicographically. Wow, that is a complicated word. Return the result table ordered by sale date. The query result format is in the following example. Alright, so we have 3 products sold on the 30th of May 2020, and the products are basketball, headphone, and t-shirt. Sold items were headphone, basketball, t-shirt. Now, of course, what I'm asking myself in this query is how can we group the products in a way that they are separated by a comma here. So if we find out how to do this, we find out also how to solve the query. So let's try to Google this. Group MS SQL group by concatenate column values. So this is exactly what we want. Here we have the example and we see the page URL abcdxyst, and the result should be ab, cd, xy, st. So this is already very good. It is the same, it is exactly the problem that we want to be solved. Let's see how you can do that. So we can do that by using for XML path. So we use this function here, and the stuff is removing the first comma before the first item, and the other items separated with comma are created with for XML path. This is what this comment is explaining here. Let's try this query here, because it looks pretty good. So we are using this user and activity. What do we have here? We have product and sell date. User activity and page URL. Okay. So just as a mental bridge, we can write user equals, what does user equal here in our example? So the page URL is the one that is concatenated. Page URL means page URL equals the products, because they are the ones that are concatenated. Now the activity and the user. Let's say the user is the sell date. And the activity is the num sold. But we actually don't have the column num sold. Not yet. So to fit our example to our use case, we have to get actually 3 columns: user, activity, and page URL. So first we have to make a table where we get 3 columns. So let's try to get this table. Select sell date, count from what do I want to count? I want to count the product as num sold. I want the product. From activities table. Activities. Let's take this one away for now. Of course, we have to group by sell date. We have 3 numbers sold on 6. On the 1st of June, we have 2 numbers sold. On the 2nd of June, we have 2 items sold. Okay, great. Then we need again the product. Okay, we want to count the product, but we want to count it over partition by sale date, so that we can get the sale date and the product out here. Cross the comma here. Okay, cool. That's what we want. So I did make the count from product as a window function. That window function means that I used over and partitioned it by sale date as number sold, because I wanted to write the column product and sale date here. Okay, why did I do that? Because this way we have 3 columns here: sale date, product, and the number sold. And this are also 3 columns in our example that we just found here on Stack Overflow. And now we can transfer this example into our use case. So we have 3 columns in the example: user, which equals, for example, the sale date. Then we have the activity, which equals the number sold. And then we have, what did we add in the example? The page URL. The page URL, which equals our product, because the page URL is the one that gets concatenated in the end, and we want to concatenate the product. Okay, so now that we made sure we have a similar starting point to this example, we can actually use the code that was written here for us and just exchange the columns, and then we can get to the right solution. So we have user and activity. We know that we need sale date and num sold. By the way, we should call this table somehow with number sold, products sold. I'm going to call this table as this one, so that we can request this table. We have to create it first here. And now we have the sale date, the num sold, and now we make the function stuff, select distinct, and here we use the comma as a separator, exactly what we need also here, plus page URL. Of course, page URL should not stay like that. It should be actually the product. From table name is, in our case, the table name is number product sold. Where user is going to be sale date, equals user sale date equals a dot sale date, and activity equals a dot activity. Of course, activity is going to be num sold. Num sold equals a dot num sold. For XML path, and this is the brackets. And now we call it as URL list, and we want to call it as products. From number product sold, And we don't group it by user activity, but we group it by cell, date, and by num sold. Okay, so let's see if this works out now. Okay, still the wrong answer. Probably we did not order it correctly. Let's see how we should order. Return the result table ordered by cell date. Okay, that is really not the problem anymore. Order by cell date. Still the wrong answer. Let's see. 30 of May 2020 we sold 3 and it was basketball, headphone, t-shirt. Looks the same to me. Now we have 1st of June we sold 2 Bible pencil. Then we have 2nd of June 2020 we sold 1 mask. And the expected output is 1 mask, and we say that we sold 2 masks on this day. So why is it calling 2 masks? Okay, so we should only count the distinct products that are sold there. So the mask gets sold 2 times on 2nd of June, but we should only count it 1 time. So let's count the distinct products, and now we should get the same test result. Distinct is not allowed in the over clause. No. What's the problem here? Okay, so let's find this count from distinct product as product we are grouping by the cell date. Now let's do another one. So this is number product sold, and this is activities and products and number sold is, so let's do this again. We select the sell date, then we select a product, which is actually no, count from distinct product should be num sold. Num sold shouldn't be that. So number of products sold is the count from the distinct product. And now we want to select the sell date, the num sold, and the product from number products sold NPS join activities A on A dot sell date equals to NPS dot sell date. Alright, this was complicated. I'm very sure there are much easier solutions out there, but I'm trying to get it work first, and then you can always prettify it. So let's think about it again. So we have called this one activities and number sold. This is how we actually have to call the table that we are requesting in the end. And let's run this code again. Alright, so it is accepted. We actually have everything the same. So let's see if this is also working in submission. It is a success, and it's actually faster than 66% of all the other submissions, which is very surprising because I would guess that this is a very long query and probably a long performance query, but it seems like it's not doing so bad. So obviously this is a very complicated looking query. So at this point, you can definitely think about how you can write this shorter, how you can make it more concise and also better understandable for other people that later are going to see that. In case you work in a work environment and people actually have to look at your queries again and maybe also have to change it and improve it. That's definitely what you would be doing now. I'm not going to do that now because this case is closed and we solved all of the 3 problems here. We solved all of the 3 problems that they are under this list, Leetcode curated SQL 70, and I actually don't know if there are still more SQL problems on Leetcode. I never worked on Leetcode before. If there is, please write to me in the description if I should do more from the easy problems. Of course, I'm also going to do the medium and the hard problems on this channel, so definitely stay tuned to this. Like and subscribe, and I'm going to see you in the next video.